or whatever time it is where you are. So I'm Chris Knowles. I'm a solo indie SideQuest ninja, and I'll be speaking today about rewinding time travel in Thinky games. Also, why I think that's a great feature to add to games that are based around planning, and how I've done that for my own Thinky game, which is Hexahedra. So let me quickly tell you a little bit about my background and the experience that got me to this point. So I got my first job in the industry in 2007 at Jagex, who most famously make RuneScape, although I wasn't actually working on games when I started. I started out writing software for things like the billing system, and that turned out to be very important for Hexahedra because it heavily influenced the way that I went and built it. But they did let me have a crack at working on games in 2009. I shipped various things there, spent about 7 years on the back end of different flavors of RuneScape. But I will mention Chronicle, that you can see there on the bottom left here and there. That was also a planning-based game, and it didn't have a rewind, but it was structured in quite a similar way, code-wise. And in 2019, I went indie. I went part-time at Jagex, and I started full production on Hexahedra in 2020. That's what I'm still working on. It's coming out next month. I'm terrified and delighted. But this is what I'll be talking about. And this talk is aimed mostly at coders, but I'm not actually going to show much code on screen. I'll keep it fairly high level. But if you wanted to dig into this a bit more and look at some code snippets from the game itself, I did do some blog posts a little while ago that cover the rewinding, how to deal with particles, that kind of thing. So if you head to the blog, you can get a bit more in-depth information there. But onwards. So why might you want to rewind time? So there's a whole class of games based around planning. You set up a solution, you see if it runs. It probably doesn't the first time, so you tweak it until it does, and then optionally you spend some time optimizing it, and there might even be some graphs and some leaderboards you can play with. So Opus Magnum, which you can see here, a very famous example. You place pieces of equipment onto the board, you program them with the tracks at the bottom, and then you watch to see if your solution produces the correct result. So here's a sort of tight little solution to one of the earlier levels. We make some molecules, they go to the output. All is well. Now, Opus Magnum is a great game. I am not here to slate it in any way, but there is one place where it can be quite frustrating, and that is where your solution goes wrong. So working out where the problem lies can be tricky, because if you use, say, the wrong command, you meant to go left and you went right, or whatever, that might not cause the solution to fail instantly. And so once you realize sometime later it's gone wrong, working out where the actual problem was is quite tough. I mean, it's just like normal software. I mean, this is effectively a program you're writing, and as with real code, the place where the bug shows up and the place where the bug is might be very different. So this is the same solution. All I've done is remove one command there, but it's not until a few steps later that two atoms smash together and we fail the level. And when the level fails, the only thing I can do to try and debug it is to reset, go back to the start, and watch it through and try to spot the error sort of as it flies past. And it would be much neater if I could just rewind to an arbitrary point in the past and just watch it back, just that little bit, go back and watch it again as I need to, go and hunt somewhere else if it turns out that's not the problem. It'd be much less frustrating and much neater if I could hunt for bugs that way. And getting that working is what I'm going to talk about today. So let me show you this in action. I will switch over to Hexahedra. So Hexahedra is in a very similar genre to Opus Magnum. It's an open-ended programming puzzle game. This is the very first level, so it's very small. We've hardly got any devices. There's not a lot of space. Everything is fixed in place. This level is really there just to show you how a factory looks when it runs. But what I'm trying to do is turn my inputs into my outputs. I'm trying to turn this cube, which is, it's mostly made of metal. It's got one blue face. The bottom's made of wood. I'm trying to turn it into this, where the blue paint has gone and the wood has gone. And if I unfold them, you can kind of compare them. And this factory is all set up to do that. So if I run it, we'll see that it grabs itself a cube. We scrub the paint off it. We set it on fire. That will deal with the wood problem. And then we can send it off to the output. And then this command here just says, don't run all the way to the end. You should start again from scratch right now. And this will just run. It's entirely deterministic. There's nothing I can do at this point which will influence the game. All I can do is watch it. But if at some point I want to go back and look at the past, I can grab the timeline handle and I can drag backwards and I can go and look and see what was happening at previous points. And I can, wiggle backwards and forwards through time wherever I need to. Things like the paint scrubbing transitions kind of will apply and unapply. And this just makes hunting for where the problem might be in a level that does have a bug, it just makes it just much nicer and easier. So now, when I was implementing this, I wasn't aware of any other games doing this, although I have since come across Manufacturer 2022 as a game in the genre that has a rewind. So it's not quite unique, but I do think it is quite nifty, if I say it myself. So what are we going to cover today? We'll start out by a high-level overview of the code structure and how it's put together and how that supports the rewind. We'll look at what game state we need to track over time so that we can put ourselves back into the past and what it takes to actually do that work to put the factory back into a previous state. Doing that in the factory caused me some problems with the UI, so I turned out I needed to track some of that state, and we'll cover that as well. And then how do we play the short chunks of gameplay backwards? So there's actually two different kinds of rewinding going on here. If you look at this timeline, this track marker here, this shows me where I am in time. When I go back over a step boundary, I trip over it, that's the point at which I rebuild the factory in the past. But when I'm moving within a step, if I'm wiggling through these VFX, how do I get that smooth movement within a step? How does that come together? We'll then look at specifically particles for that. That's going to be a Unity-specific bit of discussion. And finally, I'll cover some limitations. This works for Hexahedra because of the kind of game it is. If you're doing something a little bit different, you may find that's tough. So we'll cover some of that. But we'll start out with the code. And the first thing to say about the structure is that the code that determines what's actually happening in the factory, does this factory the player has built solve the level? That is a pure C# project, which I called Hexsim. It exists as a DLL. It is not a Unity code. And so really, Unity is just used for gathering the player's input, so we know what factory they want, and showing the results to them so they know what happened in their factory. And this turned out to be vital for the rewind, although it isn't actually the reason I did it. The rewind came later. The two reasons I did it, one was for the stats server, so I can provide these graphs of how your performance compares with others. I have a stats server that logs all these things. The friend stats you can see that are actually powered by Steam, but Steam gets its data from the stats server. And to prevent people cheating, the stats server verifies all the solutions before it adds them to the stats. And so it just uses Hexim. It doesn't need to run a Unity instance or anything like that. It can take the DLL, run it just as fast as its CPU can cope with. There's no animation or anything like that. And it makes the stats server much more lightweight. And the other reason is it's just easier to unit test it, frankly. You can unit test Unity code. I actually quite like its framework. If you have some tests that kind of rely on the Unity lifecycle, you want to create a thing, let it sit there for a frame until it's set up and check it. You can do that with coroutines. It's very nice. But that said, code that isn't wired together through scene references, get component calls, that kind of thing, it's just much easier to test. And it means you are doing a much simpler setup. You really are doing a unit test rather than an integration test, which is a valuable thing, but isn't quite the same. So how is it put together? I'm going to put a lot of UML up on the screen. Don't worry about what's in all the boxes. It is just the broad shape that's key for this. But at the top, we have the puzzle, and it knows what the user needs to make. It knows what cubes they've got to work with. It has other constraints, what devices are enabled, how big the factory is, and so on. It will create a factory. A factory has one or more workstations. Each workstation can contain up to 5 devices. They have a common base class. You might wonder where the 5th one goes. It is possible to have a device at the back behind the cube that can do things to it from that angle. We also have the command tracks, and you can have multiple of those. So eventually you can make very literal sort of physical loops, visual loops around your code, and you can have branching and so on. And the commands go into those. We also have the cubes themselves, and but this isn't a Unity project, so none of these are mono behaviors. There are no Unity game objects, but we do have this nice hierarchical structure that does represent what you see on the screen very closely. So when the puzzle wants to know what's going to happen in the next step, it asks the factory to work that out. The factory asks each workstation to sort out what it's doing. It will look at what the next command to execute is, and that might be something like trigger the device on the left, or it might be take the cube you've got and send it down to the workstation below. And so the workstation might need to ask a device to sort out what's going to happen, how the factory is going to change. So it will do its job. And then the workstation can then, based on the result of that, and if it's a device that causes the logic to branch or anything, it can work out what the next command to execute is. And that gives us everything we need to see if the factory solves the level. As long as we can get the information into Hexim about what factory the player wants, we can then run it, and we update its internal state as we go, and we can see, is the player going to solve the level? Because unless they've set up a degenerate solution that never resolves, either we're going to get to the point where they've shipped all the cubes they need to, and they've successfully completed the puzzle, or they're going to get some sort of failure. So they're going to ship the wrong cube, that causes a failure. They might smack two cubes together. Maybe they've got a cube with a payload inside and they rotate it, and now there's no base and the payload falls out. That sort of thing. So we can check solutions. This is enough to build the stat server into when a player claims they've solved a level in a certain time, we can verify that they have. But how are we going to tell the Unity client how to display what is going on to the player? And obviously, I don't want to do this. Public member party, everything's public. Unity can poke whatever it feels like. It's all available. I don't want that. That is a spaghetti nightmare. I want a clean separation between the two halves. And so what I've done is I've made a very similar looking hierarchy on the Unity side to show the player what is going on. So Unity has a U puzzle. I decided it was just slightly easier to give it a unique name. But that sets up a puzzle on the Hexim side. It passes it the puzzle data. If we're loading a solution the player has already worked on, it passes in that initial state as well. The puzzle then sets up everything underneath it that we've already seen. And then on the Unity side, well, we have a U factory, which has a U workstation and so on. And so when the Unity side needs to know what is happening in the next step, well, it asks Hexim to work that out. And Hexim responds with a big list of events that contain all the information needed to display that step to the user. So if we do trigger a spray painter, for example, on the Hexim side, the spray painter object will produce a trigger device event. And that is just there to tell the Unity side, the U spray painter, that it needs to visually trigger the device. It needs to move from the dormant position to the active position. It needs to trigger the VFX of the paint spraying. It needs to play the sound effects and so on. And also, if there's actually some painting going on, we also send a set face front color event, which will set a cube panel's color. But the reason those are separate is that if there's no cube there, you still want the device to animate and still visually spew its paint out. So you still want the trigger device event. But if nothing's actually getting painted, you don't send a set face front color event. And these events get generated by the spray painter. They get passed up the chain to the puzzle, which then sends them across to the U puzzle and then down. And the events all know, where they happened, what they relate to, so we can filter them and pass them to the correct U spray painter that then knows, okay, fine, I can trigger my animations. I know how to do that. And we're away. And if there is a set face front color event, then the workstation's cube receives that. And this structure makes me think of the OSI networking stack model, if you're familiar with that. Excuse me. So this describes how messages get passed between two programs running in different places. And you can think in terms of a high layer. So at layer 7, we've got one program sending a message to another. But if you think about that happening, that same process at a lower layer, at layer 4, for example, you would be thinking in terms of setting up a TCP connection between those two computers and sending the data in packets. And then down at layer 1, you're sending bits along a connection. And in fact, sometimes people will talk about layer 0, which is I've got a wire and the voltage goes up and down. And so in a similar way, we have a way for each part of the Hexim stack to send a message to its Unity counterpart, but it's not actually done directly. The spray painter doesn't send a message to the U spray painter. We pass messages up and down the stack, and there's only one place where they swap sides. And that really is the equivalent of this is the wire with the voltage going up and down. So events go one way. When the player is still planning and they're editing their factory, that information goes the other way. So the Hexim knows what it is that it needs to work with. And it turns out that this event stream was the thing that unlocked the possibility of rewinding the factory. And I really did just have this massive light bulb moment when I realized, oh, hang on, I can do this. If I can record the state of the factory at the end of a step, and if I can then rebuild that, and if I've then got all the events that have happened since then I can just replay them and it will happen exactly the way it did before. It'll be identical. By the way, there are also some other benefits to this approach. So separating the logic from the display and using a stream of events from the logic to power the display. So I designed something similar for the back end of Chronicle that I mentioned before, back at Jagex. That was a 1v1 card game, came out about 10 years ago. Sadly, it's not still around. But it was a planning-based game. So the idea was that you have an adventurer, and so does your opponent, and you're plotting out an adventurer for your character to go on. And so you place up to 4 cards in a row, and they might be something like beat up a small monster to get some money, buy a big sword, beat up a bigger monster for greater rewards. But your opponent is also playing their cards, and when they resolve alternating. And so the idea of the game was you could also interfere with your opponent. So if I kill the monster and get the gold, and then my opponent steals my money, well, now I can't buy the sword, and now I'm facing a dragon with my bare fists, and I'm getting absolutely pasted into the floor. So you could interfere with each other. So the planning involved what you want to do, but also how you disrupt your opponent. And again, the game had a Unity client, but the logic of what happens when we play these cards, that was pure C#. It existed both on the client and on the server. And we sent it a stream of events. So when you submitted your turn, your opponent submitted their turn, the server would work out what happens, send a big load of events back across the network, and your client would play those out to see what was happening. And also stuff that was happening between matches, your persistent stuff, when you leveled up, when you unlocked some cards, that kind of thing, that we handled with a series of events that went into a database, and we could then play through those to derive your current state. And again, that's the bit where it looks most like a billing system. And the thing is, the data science team wanted to run loads of analytics on Chronicle. They wanted to know, what cards are people playing in a match? Are there cards that are being played way too much because they're too powerful? Are there cards nobody ever plays because they're awful? How are players interacting with the game when they're not playing a match? And essentially, we had these massive event streams just ready to go. And we could just send it to their data warehouse, and they were happy. They were very pleased. And it was all essentially free. We did add 1 or 2 events for them. So we had an event when you're planning, when you put a card down, that would trigger an event. If you picked it up and changed your mind, that would be another event. So we could see how players were interacting with the planning phase. But really, by and large, we got pretty much all of these analytics for free. And they could tell us which cards are popular. They could tell us, a very contentious question was, is going first a really big advantage? Is it balanced by having an extra card if you're going second? Turns out, thankfully, the answer was yes. But we could prove that because we had all these events. So in all seriousness, do consider building your Thinky games like billing systems. But anyway, that aside, back to Hexahedra. So the light bulb has gone on in my head. We can save the list of events for each step. And in fact, that's pretty easy. What other data do we need to store in order to support going backwards in time? And the key thing here is that obviously you want to store as little data as possible. That's just easier. And so you want to take snapshots of the past when there is the least amount of stuff going on. And fairly naturally, that turns out to be the boundary between steps. So during a step, things get pretty busy. Cubes are moving. They're being spray painted. Sides are being taken off them. They're being hit by lasers. Things are being put inside them. There's a lot happening. But at the end of a step, all of those changes have been resolved and things are pretty much at rest. So we don't need to worry about how is this cube rotating, because at the end of the step, it has rotated. And all we know is one step it was like this. Now it's like this. So what do we need to store? Clearly, we need to store the state of the cubes in the factory. And this in particular is where things are a lot quieter at the end of a step. So during a step, a workstation might have to worry about 9 different cubes. There's the one in the middle. There can be 5 coming in from different directions, either because they're arriving from a different workstation or a sorcerer is putting a new one in. So you can have one arriving from the back. You could be teleporting a cube out. You could be teleporting a cube in. And also you could be sending the cube in the middle off to somewhere else. But at the end of the step, when all the incoming cubes have merged into one in the middle, and actually if they're going to smack into each other, then we won't get as far as the end of the step. We'll have already stopped and said, no, sorry, that's an error. You'll have to fix that. The cube teleporting in, that will merge. The cube teleporting out, well, that's gone. So the only cubes we have to worry about are the one in the middle And if we are sending a cube to a different workstation, that movement takes 2 steps. And so at the end of the first step, we're just about to hand it over. It's just about to become an incoming cube for the next workstation. But for now, we're in charge of it just before we hand it over. I said we need to store panel rotations. That's something that doesn't have any effect on gameplay, but it does have an effect graphically. So really all that matters is what is this cube made of? Is it made of glass? Is it made of wood? But I do want to store the rotations of the physical or the actual game objects so that when you rebuild the past, planks don't suddenly rotate 90 degrees or something like that. But that's purely a visual thing. Now, there is some device state, but thankfully not a lot. The major one is the panel storer. That can take a panel off a cube and hold onto it, and then it can put it back later. So I need to know what it is that has got in storage. The only other device that can change during a run, we have colored panels that you can use to reflect laser beams of matching color. And if you have one of those at the bottom of a workstation and you drop a blob of paint onto it from the top, you can repaint it during a run, and now it will reflect a different color of laser beam. Excuse me. Other than that, though, that's pretty much it for real state changes. Some of the devices trigger quite late. So the laser, which measures the color of a cube, you don't want that to fire when the cube is being painted because it's not really clear what's going to happen. So it triggers right at the end of the step. And by the time the step is finished, the laser has done its thing. We've measured the cube. We know which way we're going to branch the logic. That's fine. But the device hasn't had time to physically move back to its dormant position. So for those late triggering devices, we just need to store at the end of the step, was it in the active position or the dormant position? For tracks, we need to know which command we're about to execute, and also actually which command we just have executed. So if you look at the track marker here, this line that moves along shows us exactly where we are in time, which direction it moves in, and how it rotates. If we're moving between tracks, it sort of drops down to the next track below. Animating that properly means we need to know both where we're about to go and where we've just been. For the targets, we need to know when the cubes are shipped, so that if the player rewinds and the shipped cubes come back out of the shipper, we need to decrease the count that the player sees, so that tracks. Some of the sources, when you trigger them, will give you a cube at random from a fixed list, so we need to know which cube we got so we can replay that. And the teleport buffer can store up to 3 cubes, so we need to know what their state is as well. So there are a fair few things here, but this is a very manageable list. And with that and the event stream, we've got everything we need for sort of stage 1 rewinding. I implemented the rewind in 2 stages, and this is what we need for stage 1. And one really key thing here is that all of this happens on the Unity side, because that's just where we handle the playback. So Hexim does not know anything about rewinding. It just goes to sleep, and it only wakes up and does something when the Unity client says, hey, can you tell me what happens in the next step? So when Unity is replaying the past, it just rebuilds its game objects, uses the stored events, and it only asks for new ones once it's caught up with the present. And so that is a huge potential source of complication completely avoided. The underlying factory simulation does not have to go backwards. And so armed with that, we have the first version of the rewind. This is a very old video from before I paid a professional to make me a proper UI. But you can see that I don't rewind smoothly through time here. When I grab the timeline handle, we're going to jump back to the boundaries of steps. Here we go. But then when I play forwards again, we do smoothly go forwards because, of course, at that point, I'm just doing exactly what I did last time, but we go back in discrete chunks. But we'll tackle this bit first. What do we need to be able to do to get this bit working? Oops, there we are. So the first thing I need to do is, based on where the player has put the handle, I need to get the correct index into the historical data. I store 500 steps in the past. So if you go far enough, you start losing the ability to go right back to the start. Partly that's just so the amount of data I'm storing isn't totally unbounded, but actually it's more to do with the fact that if you store any more than that, it becomes difficult to accurately scroll through time because a small movement of the timeline handle moves you through quite a lot of steps. So once I've worked out where I'm going to go, I can tear down the existing cubes and I can recreate the cubes as they were in the past. And we're going to need to deal with the cubes that are in the factory and the cubes in the teleport buffer, because we can see those. There's a visual representation of those that we need to be able to see. Now, here we are throwing away a load of game objects and then making some new ones. And the initial implementation that was naive had a huge impact on performance. It was very slow, and the more quickly you scroll back and forth through time, the worse it got. But I was able to almost eliminate this by using some object pooling. So when I throw away the old cubes, the game object that is sort of represents the entire cube and manages it, that does get thrown away. But the objects that are the meshes, the actual graphical bits of the cube, those individual panels, they go a panel at a time into a pool. In fact, there are 3 pools. There's one for the metal, one for the wood, one for the glass, because they have different meshes. But I can pull those, move them out of the way, and then when I want to rebuild the cubes, I can pull from the pool. And actually what I get back is almost certainly going to match what I need, because if I'm going back one step, well, there's only so much the cube can have changed, so I can get some exact matches out of the pool, and I don't have to worry about setting shader variables and so on. Yeah, and this just gives us a much more efficient way of rebuilding the past. I can set the track state back to where it was, knowing where I'm going next and where I've just been. I can move the marker fairly easily back to there. For the ship counts, I can make sure that the readout, the number I've shipped is correct, and so on. And this works. This will let you rewind, and you can then play from where you are. Everything is fine. But it did cause a bit of a UI issue. So you may have noticed that it's a little bit hard to see around the back of a cube. So, where are we? You know, I can pan the camera a bit, but I can't really see what's going on around the back. So to make that possible, you can click the cube and get a visualization. It works exactly like these ones. And I can look around the cube, I can unfold it, and so on. And this bit of UI is anchored to that cube. So if I move the camera, it sticks to it. When it moves up there, you know, the visualization goes with it. Now, obviously, if I'm rebuilding in the past, the cube it's attached to no longer exists. And there's no intrinsic way of knowing if the cube I've just built should have its visualization active. And so the problem I had was that when I rewound, the visualizations would shut. And so to fix this, I simply assigned an ID to each cube as I made it, and that gets saved as part of the cube data. And I then maintain a list of which IDs have their visualizations active. And so when I rebuild a cube, I restore its ID, I check the list, and if it needs a visualization, I can grab one of those. So the UI for the visualization also goes into a pool because that was having an impact on performance. So I grab one of those, build a cube inside it, and we're off. There's a slight trick to this, even when you're playing forwards, which is when you merge 2 cubes together, one of them consumes the other. So if the one that is being consumed has its visualization open, you then need to track that the new cube now needs its visualization to pop up. But yes, this is now fixed. So yeah, on a rebuild, we don't lose the visualization. Right, so that's great. That is step 1. That works, but how do we do the smooth rewind? How do we get to that nice back and forth within a step bit of action that I can do? Now, a thing that turned out to help a lot was that I was already managing time centrally in Hexahedra. So actually, pretty much all the device or a cube cares about is knowing how far through the current step we are. It doesn't really care much about how much it's moved since last step. So rather than getting them all to worry about delta time, I manage it centrally, and any cube and any device can say, how far through the current step are we? And this is particularly handy for the devices that are animated in code rather than using Unity animations. So the cleaner, when its arms extend, that is a genuine Unity animation. But the fact that the brushes spin, that's handled in code. When a source's door opens, that's just a very simple rotation of a game object. I handle that in code. And all I do is some interpolation. I know when the door is supposed to start opening. I know when it ends. And based on the current time, I can do a lerp, a linear interpolation. And if we're before the start time, it's 0. For after the end time, it's 1. In the middle, it's somewhere in between. And I just set the transformation to however far through that bit of progress it should be. We do the same with the cube changes. So if a cube is being painted, it gradually changes to the new color. And again, we can do a lerp for that. And we then pass that through to a shader variable, which merges the 2 textures for us. Now with the real animations, obviously that's slightly trickier, but when we detect that the player is manually controlling time, well, actually we can just lerp it again. turns out. We know when the animation is supposed to start, when it's supposed to end. We can work out how far through the animation we are. And you can actually say to Unity, set the progress of this animation to this value between 0 and 1, and it will take care of that for you. Now, when something happens in a step which is sort of a one-off, I use a set of Boolean flags to track which ones have occurred. So, for example, with the saucer, when it starts out, when we grab a new cube, it starts out, the cube is a child game object of the device itself, so that when it moves down, it moves with it. But then once it's got outside the cube, outside the device, the workstation becomes the parent and takes over control. And so if we see that we're past the point where that's supposed to happen and the flag isn't set, I set the flag, do the transfer, and we're now in the correct state. And we also do this for things like triggering the VFX and the sound effects. But now, in order to rewind, these changes need to be reversible. So if I realize I've gone back to before the point where the handover should happen, and the flag is set, I unset the flag, hand the cube back to the device, and we're back to where we should be. And this all works visually, but I did find one slightly more subtle issue, which is that when the player is controlling time, because I don't want Unity to do anything, I set Unity's own timescale value to 0, so everything's paused. But when you do that, Unity stops running physics updates. And that meant that if the player rewound time and moved some cubes around the factory, if they then tried to click on a cube to get its visualization to appear, the raycast wouldn't see anything, because as far as it's concerned, the cube is back where it was before. That turns out, though, to be easy to fix once I finally worked out why that was bugged. And so now whenever the player stops dragging the timeline, I call physics.syncTransforms, and that sorts that out. At this point, we've handled everything except the particle systems. And here, unfortunately, we run into the problem that Unity has no way of running a particle system backwards. So if you want to make a particle system go back to a slightly earlier state, your only option is to reset the particle system and then use the simulate call to say simulate for exactly this amount of time to get me where I want to be. And I was dreading this, possibly sinking the smooth rewind as a feature. I thought this is going to be awful. Actually, to my great surprise, it isn't. It is actually really quite quick. It's very high performance. Unity's particles are pretty fast, it turns out. If people do struggle, I do have a low performance option where when we're rewinding, I set the VFX time to a particular point. So for the spray painter, I pick a point where the spray is in full flood and we've got a nice cloud of paint, and I just hold it there. So rather than simulating particles, I get it to that place once, and then even as I scroll through time, the particles just stay put. One thing that is going to cause problems, though, is using random seeding. So when you restart the particle system, by default, it will pick a new random seed when it replays. So then if you say, play back to where I was just before, you won't end up in a similar position. It'll look very different. So I've got a video of that happening here. So we play the spray, it's fine. When I rewind, I get this sort of chaotic billowing effect. Forward is nice and smooth, back is rough. And that's because every time I go backwards, we've picked a new seed, and the particle system doesn't end up in the same state. But this is easy to fix. You can tell the system to use the same seed every time. And in fact, if in code you manually set a seed for a particle system, that will set the flag to say, always use this one. And so I've set things up so that every spray painter will have a different seed, but an individual spray painter, whenever it restarts, will use the same seed every time. So that means the rewind works smoothly, but every particle system looks slightly different. The other thing that may catch you out is where the emitter is. So if the emitter is going to move during the run of the particles, if you rewind and you resimulate all in one go to where you want to be, it's going to resimulate with the emitter all in that position. You won't get the movement. And this caused, probably the most obvious problem was with the heater with its flames. So it moves down while the flames are still playing out. And so when I rewind, the flames vertically move with the heater because they're being emitted while the heater is out of position down the bottom. And obviously this had worked fine until now, but with the rewind, the fix simply was to attach the emitters to the workstation so they don't move up and down with the device. The device is still in charge of them, it still turns them on and off and manages them in other ways, but we get around this problem. And about half of the devices with the VFX ended up doing this for this reason. But you may still need to do a little bit more management. If I play the video again, you'll notice the heater kind of wafts backwards and forwards across the cube as it heats to get the flame all there across it. And so even though it's not the parent of the particle systems, it needs to sort of manually move them so they keep up with the physical game object. And it does also mean, actually, when I rewind, that sort of wafting doesn't rewind. But thankfully, I can get away with it because it's in the plane of the camera. Oh, because sorry, in the axis of the camera, you can't really tell, so it doesn't look too bad. And I just didn't worry about it at that point because I'd made it look good enough. But yes, so watch out for that. And the final wrinkle you might find is that when you've called simulate on a particle system, the particle system then won't update in the normal way until you tell Unity, okay, you take over again. And there is no resume call on a particle system. The only thing you can do is call play. Now, if you have a one-shot particle system where you tell it to play, it runs for a few seconds and then stops. So the spray painter does that. It sprays some paint for a bit and then it's done. That works absolutely fine. So at no point after simulating will calling play make it restart. So if you're still emitting particles, it just carries on. If you finished emitting particles, but there are still some playing out, it just carries on. If you're off the end and there's nothing left, it'll go, yes, I shall play. Oh, actually, no, I don't need to. I'm just going to stop. But if you have a particle system where it loops, and so you call play until you want it to stop, and then you call stop. If you call play to resume it, you'll start emitting particles again, which is a bit awkward. And it turns out the fix for this looks silly, but works absolutely fine. You just call play stop, and so play says unjam yourself, start playing, particles out again. But stop then says don't emit anything, whatever you do, and that will need to you'll need to do that in order to get it working. But with all of that done, it works. We are there. We have all the pieces in place. We can rebuild the past. We can handle smooth movement within steps. Everything works exactly as it does the first time. It's 100% reproducible, and it's lovely. And yeah, the player can hunt for bugs to their heart's content, and we have mission accomplished. But I did say I would cover some limitations. So I think there are two main ones to consider. The first is that Hexahedra doesn't use the physics system for anything that affects the gameplay. So there are particle systems that are affected by physics. So some of the flames have a negative gravity, so they bend up as they go. But nothing that's crucial to where things are uses physics. So even when I said you can accidentally drop a payload out of a cube, that doesn't use physics. I just use the Newtonian equation, S equals ut plus a half at squared. And so I know when it started falling and where it started from. So at any point in time, I can work out how far down it is. And if I needed to rewind physics, things would be much nastier. I would need to save a lot more data a lot more often. Of course, the nice feature of not needing Unity running on the server, that would go out the window. The only other option would be to integrate with a third-party physics system, but then I need to put that into Unity as well. It gets a lot more complicated, and it's a much harder problem to solve. The second thing that would make life more awkward would be if the player could interact with the factory while it was running. Now, this is not an insurmountable problem. I could capture the input when it happens, and I could be ready to replay it at the right instant on the replay. But obviously, I would need to record that. I'd need to be able to send it to the stats server. But yeah, that would make life a little bit more tricky. And you could also make a very interesting game, but a very different game where the player can rewind and replay and then interact with during the replay. That's a very different beast. Not impossible, but obviously a bit more complicated. But if you are doing something planning-based, I'd really like to encourage you to think about allowing players to rewind time. I think it's a feature they'll really appreciate. And yeah, if you want to have a play with the rewind, there is a demo of Hexahedra on Steam right now. That's free, and it comes out next month. But thank you very much for listening. Does anyone have any questions?
Thank you so much. Thank you so much for the talk. I feel like somebody could re-implement that from scratch with the amount of detail you gave. Like, it was very thorough, very technical. So thank you very much. There was a brief discussion of games that use time reversing in their mechanics. Of course, Braid came up and Trace came up. And actually, there's an interesting question, is because there is a talk about Braid's rewinding as well. were you inspired by that at all, or did you come at this in your own kind of way and just approached it? Because obviously it has different requirements as well, because it's part of the mechanics there.
Yeah, because when I said it was almost unique, I meant kind of really just within the planning game. Obviously, Breed has been out for years. Yeah, I mean, it was because I didn't set out to make a game with a rewind in it. I just that gif of the guy with his head exploding and galaxies everywhere. I just had that moment of like, oh, I can do this. Hang on a minute, let's get right on that. Yeah, so it wasn't. I can't remember what made me think of it, but I didn't set out to do it. But it turned out that, thankfully, the way I'd structured the game meant it worked, meant it was possible. So that
at the time, was it a case of I would like to have this as a feature, but I don't really think it's going to be possible until you had that galaxy brain moment? Or had you not even really been considering adding it?
I hadn't really thought about it. I mean, it was a thing that had always been frustrating about that kind of game. And I thought, well, it'd be nice if I could just go back and hang on. I reckon this is doable. Yes. And I got Post-its out and started scribbling very quickly.
It's actually impressive. Something you see often, something I've seen often is people making their game, they're really far into the game, and it might not be time rewinding to the like the kind that you're doing, but just like undoing or something, and somebody wants to add undoing at a later point in the game. It can become incredibly difficult if you haven't planned for it in advance and like basically implemented undo right from the beginning. So it's pretty impressive that you were able to implement this despite not planning for it at the beginning.
Yeah, I mean, it was just serendipitous that it came out that way. I did also spend a very long time implementing an undo system, but I knew I wanted that. I knew I wanted that from the start.
Right.
Yes.
All right. So a question here from the chat from Jonathan. Any thoughts about replaying snapshots versus replaying events? I guess you spoke about how you use the kind of steps as snapshots. Well, I suppose the question might be around like kind of the granularity of those snapshots, for example, maybe like, because I suppose you could, in some games, I believe they take snapshots further apart and then kind of replay the events from one snapshot to a later point.
I think because I then don't have to worry about rewinding Hexim, if I'm taking one every step, then I've always got all the data I need. Otherwise, I suppose I could save less often. So when I'm not screen sharing anymore, am I? You
are still screen sharing.
So when I trip over a step boundary here, so if I go over back to this step, what I actually do is I immediately rewind right back to the start and then play forward until I get to where I need to be, because I have to rebuild it here and then jump forward. So I guess if I was saving less often, I would have to do more of that in one go. If I was only saving every 5 steps, I just have to do more of that. But given the amount of data, it's not a memory concern doing it every step. And the code is no more difficult. I just have to run it more often. So I think there's probably but certainly for Hexahedra, there's no particular advantage to that. If you had to store a lot more data, maybe that will become a consideration.
Another question came up. This might end up being just a game recommendation. If you haven't played the game, it says, have you played It's a Wrap? And how do you think they implemented it as timeline scrubbing?
Is that the musical one where you sort of have band members moving through a level?
No, it's not that one. So It's a Wrap, if I remember correctly, is like it's a platform where you're playing as like an action hero, and you have to. I'm not exactly sure. I can't quite remember how it works, but you use the timeline to like avoid obstacles. Like, so there's obstacles falling and stuff, and you're trying to dodge them. And you scrub through the timeline. So I guess the answer is I haven't played it.
Yeah, I haven't played it. It may well do something similar internally, I guess. But at some point, you're going to have to store a bunch of states and know how you got between them in the first place, I guess.
Absolutely. Yeah. Thank you so much, Chris, for joining us. All right. Thank you, Chris.
Thank you.